Okay, so we're going to look at divisibility tests next. So you might sort of pause and have a think, do you know any divisibility tests for those numbers there? And then we're going to start talking through them. Okay, so if we start with 2, which is probably the one everyone knows, so the last digit needs to be divisible by 2. Or in other words, it needs to end in a 0, 2, 4, 6, or 8. Okay, so in terms of how we'd write our working out, because that's one thing I want to focus on here. Okay, for example, if we're given the number 1428, okay, what we can say is that 2 is a factor of the last digit 8, and then we can say therefore 2 must be a factor of 1428. Okay, so that's the type of working I'd expect to see to ensure that you get the marks. Okay, so that'll be the one for 2. Now, our next one, 3. So the sum of the digits are divisible by 3. Okay, so let's take the same number again to 1428. Okay, and you're just going to add up all of the digits. 1 plus 4 plus 2 plus 8. Okay, so that gives 15. Okay, and then 3 is a factor of 15. Now, if you want to show that clearly, actually, that 3 is a factor of 15, what you can do is write the 15 as a multiple of 3, so 3 multiplied by 5. Okay, and that clearly shows that 3 must be a factor. Okay, and then therefore, we can conclude that 3 must be a factor of 1428, since 3 is a factor of the digit sum. Okay, right, next one, let's look at 4. So the number formed by the last 2 digits is divisible by 4. So this one, in terms of why it's true, well, because 100 is divisible by 4, that means 200 is divisible by 4, and so on. So essentially, almost you get a reset every time you hit 100. Again, it's just like counting in multiples of 4 again from 0. So if we take the number 1428, we're now looking at the final 2 digits. Okay, so 28 is equal to, and if we were writing it as a multiple of 4, it would be 4 multiplied by 7. Okay, so then we can say therefore 4 is a factor of 28. And then therefore 4 is a factor of 1428. Like that. Okay, and that would be the test for 4. Okay, so let's have a look at 5 now. Okay, so the last digit is a 5 or a 0. I think most people tend to know that one. Okay, so we only look at the last digit. Okay, so what we would say is the last digit is not 5 or 0. So 5 is not a factor of 1428. Another way of saying it is that the last digit should be divisible by 5. So we could write it out in a very similar way to how we wrote it out for 2. Okay, so let's look at 8 then. Not so commonly known. Okay, so for 8, we'd be looking at the last 3 digits and whether they are divisible by 8. The reason being is because 1,000 is divisible by 8. Okay, so essentially you get a reset every 1,000, so you only need to concentrate on the final 3 digits. Okay, so it works in the exact same way as 4, okay, but you're just going to focus on those final 3 digits instead. So for 1,428, you'd have to look at 428, which is not so straightforward to do. Maybe without a calculator, you might have to do a short division just to check that one. Okay, so 9 is next. 9 is very similar to 3. Okay, it's the same process, but we need the sum of the digits to be divisible by 9. Okay, so you would just add up the digits like we did before, which gave us 15. Okay, and 15 is not divisible by 9, so therefore, if we write that out with right, 9 is not a factor of 15, therefore 9 is not a factor of 1428. Okay, one that's not in the table is of course 10, which you're perfectly entitled to use. If it ends in a 0, 10 is a factor. Okay, the final one is 11, which is perhaps the most elaborate one. Okay, so what we need to do, if we take our number 1428, okay, the first digit we're going to add, the second digit we're going to subtract, the third one we're going to add, the fourth one we're going to subtract, and so on in that fashion. So the calculation we want to do, so we don't want to add all the digits up. Okay, the calculation we're going to do is positive 1, subtract 4, plus 2, subtract 8, like that. And you just keep alternating like that regardless of how many digits you have. Okay, so if we then calculate that, so we get negative 9 from that. And then we can conclude that 11 is not a factor of negative 9. Therefore, 11 will not be a factor of the initial number we started with, which is the 1428. Now, this is a good time just to remind you, if you had got 0 out of that calculation, okay, then we could conclude that 11 is a factor, because remember, 0 is divisible by any non-zero integer. Okay, so just don't forget that one, as I think it's a common mistake. Now, sometimes you will be given an algorithm to test for divisibility by another specific number, like for example, 7 wasn't in there, and you might just have to follow the steps. They might give you a written description and you'll have to just carry it out on the number.